Everyone, Archikosa here. Welcome to my session Ancova. So analysis of covariance. So here basically we are focusing on the covariance of a complete randomized design with one covariate. So in this case it's just the combination of the CRD and the applied linear regression. So we are going to conduct the analysis of covariance and test for the significance of covariate. So also construct the confidence interval for the adjusted treatment means and also the between the two adjusted treatment means. So for our conduct for analysis of covariance, we are going to test for if the means of different treatments are equal like we did in CRD, but right now the difference is now we are dealing with two variables, x and y, where x is just the covariate variable and y is the response variable. So here we are going to treat it the same way we used to treat in applied linear regression. So what basically you are going to do, given the set of data, you are going to go to your calculator, then you press mode, then from mode you'll have these options, then you press 2, then you also press 2, then you're going to input your x values per each treatment and your y values per each treatment. Then you find your variance, summation of x, summation of y, summation of x squared, summation of y squared, summation of x times y per each treatment. Then you do the same. That's how you basically will solve. So let's just solve this question that is here given here to us. So we are given a scenario that a Katahona Eget factory is to replace its old machine and must change among the three types now available on the market. One of each type, A1, A2, and A3, is borrowed for testing. The 21 workers are randomly allocated, 7 to each new machine. Each worker is timed for assembling 10 widgets using the old type of machine, and x in second is the average time taken. Then, after practice, the worker is timed for 10 widgets on the new machine, with y being the average time in second. So in here you are given your double summation of x. So this value 5572 is just the sum of 23 times 22 plus 25 times 24 until 33 times 32. So you are also given the double summation of yij all squared. So you take each and every value of y, you square it, then you sum all of them until 32. This is the value you are given even for the x. So this is it. So you have to conduct the analysis of covariance. So you'll have to write your null hypothesis, which is this, and the alternative is this. Then you have to calculate to find the f-cal, which will be given by the SST adjusted divided by MSE adjusted. So we need SSE adjusted, which our SSE adjusted is given by this formula, SSE minus E xy squared all divided by EXX. So this part is our SS reg adjusted. So which ESSE is the same as EYY. So this part is still it. So it goes with the degree of freedom T into R minus 1 minus 1. So and our SS reg adjusted goes with a degrees of freedom of 1. So here SSTO adjusted is given by SSTO minus SSXY all squared divided by SSXX. So where this part is our SS reg. So SSYY is the SSTO. So with the degrees of freedom RT minus 2. This is minus 2 because we're having two variables x and y in this case. So our SST adjusted is given by this SSTO adjusted minus SSE adjusted. So it's just a matter of plugging in, then we'll simplify our SST adjusted to SST minus, then we have SS reg plus SS reg adjusted. Firstly, I'll start by finding SST adjusted is given by this formula, SST minus SS reg plus SS reg adjusted. So you know SST is given by this. So what is this? So let's just calculate. So here you can see, or we're given the sum for the y. So as you can see, according to this, we're going to take this value, we square it, plus this value, we square it, plus this value, we square it, then divide by number of replications, which are 7 when we count here. So minus, so the overall sum, so I'm going to take 188 plus 191 plus 184, then I square it, then I divide by the number of treatment times the number of replication. The number of treatment, there are 3, so I'll say 3 times 7, which is 21, which is our n is 21. Here, as you can see, 21 workers here. So let's start. To make it simple here, you can just take 1/7 out, then you say open bracket 188 square plus 191 square plus 184 square. So let me just write it that way, you'll understand. 1/7, then 188 square plus 191 square plus 184 square, then minus 563 square, all divided by 21. So I'll write my final answer now. So I'm getting 3,524. You can confirm if you are getting the same answer. So moving further, we'll need the SS reg, which you know is given by SSXY squared, all divided by SSXX. So what is this equal to? Which is the same as the double summation of xy minus 1/RT, the overall sum of x times the overall sum of y, all squared divided by the double sum of x squared minus 1/RT, the overall sum of x all squared. So as you can see, we already have this here. The value is here. For this part, it's 15,572 minus 1/21 into. So we just add for overall sum for this, we add 197 plus 178 and 198. What do we get? We get 573. Then multiply by the overall sum of y, we already did it, it's 563, as you can see here. Close, then all divide by. So this we are given also, it's here, can you see it? For the x squared, so this part here is 15,893 minus, then this part, so it's 1/21 into 573 all square. Don't forget to have to square this part, all of it. So this is the value for SSXY, and this is the value for SSSX. So the reason I didn't round it off, I don't tamper with my answer, then is equal to, I'm getting 170.974. That's my SS reg. So let's now find my SS reg adjusted, which you know carefully, it's EXY all squared divided by EXX, which is the same as this one. So this value we have it, so 1/20 R is 7, I mean. So you'll take which means you are going to say this times this plus this times this plus this times this, then all divide by this part. You also have it, and for this one you are going to take each x value you square you add them. So let's do that. So this is what I'm talking about. You can see, so 1 over 7, then this part here, it's 197 times 188 plus 178 times 191 plus 198 times 184. As you can see here, this times this plus this times this times this. So divide by the denominator part, this value you have it, which is this here. Then you can see minus 1 over 7. So we take each sum of x by treatment to square. So 197 square plus 170 square plus 188 square. So my answer is, I'm getting this value as my exy over exx as this value. So the square of this divided by this, I'm getting my SS reg adjusted as this 217.452. So now I can calculate my SST adjusted. So my SST adjusted is given by SST. If you recall my SST, I got 3,524. Then I'll have to subtract my SS reg, which is 170.974. Then I'll have to add the SS reg adjusted. My answer is, so my SST adjusted is 50.002. So let's calculate the SSE adjusted and SS total adjusted. We'll come back and confirm this if we did the correct thing. I'm looking for SSE adjusted now, and remember my SSE is given by the double summation so of y ij square minus then this 1 over r the summation of y I dot all square. This is my SSE, which you record it as your EYY. So we already have this value, so we're going to use 15,327. Then we have to subtract 1 over 7. Then we're going to take each value of total sum of y we square, then we add, so we know it. I mean 188 square plus 191 square plus 194 square. So the value they're going to get here, it will be our SSE, which is 229.714. So now let's calculate the SSE adjusted. So our SSE adjusted is given by 229.714 minus, so this part, as you know, it is our SS. It was our SS rest adjusted, so which you recall it is 217.452. So our answer now is, so we're getting 12.262. Yeah. So our SSTO adjusted will be given by SSTO minus SSXY all squared divided by SSXX. So we need our SSTO, which you know is just the double summation of y ij square minus then 1 over RT, then the overall sum of the yth all squared. So what is this? If I recall, this value is still the same, is 15,327, then minus 1 over 21. Then we did the overall sum of y, which I recall it was 563 all squared. So we'll get our answer as, so we are going to get this as 233.238. So let's confirm if our SSE was correct. Then I'll have to subtract my 229.714 from there. I'm getting my 3.524. So my SSE was correct. So let me confirm SSE adjusted if it's correct also. SST adjusted. I'm confirming SST adjusted, so this must be given by SSTO adjusted minus SSE adjusted, where you know your SSTO adjusted in this case here is given by 233.238 minus that value, the SS reg adjusted, which was 170.974. So what do I get? So I'm getting 62.264. So which means indeed my SST adjusted, it will be this value 62.264 minus 12.262. I'll get the value which is 50.002. So which means we were correct. So in order for us to find SST adjusted, we can even find it without finding SSTO adjusted and SSE adjusted. So that's how we did it. So now we can construct our ANOVA. We have everything which we need here. So let's draw it. So this is our ANOVA table. So this is the degrees of freedom for the adjusted regression, then for the adjusted treatment, for the adjusted error, for the adjusted total, as I've shown you before. So this one is the values for the sum of squares. Now we need the mean square, sum of square. So this one, since the degree of freedom is 1, is still the same value. For this one, it's 50.002 divided by 2, which is 25.001, and the last one is 12.262 divided by 17, so 0.721. So now we need